Hey everyone, welcome back. Today's topic of discussion is measures of central tendency. We have already seen what data is, how it is collected, how it is presented in the form of graphs, pictures and text. Now we use statistical tools to use the data and infer data. Before we delve deep into what measures of central tendency is, I would like to initiate with an example. Suppose there is a student X and we have considered his marks in 5 subjects of a test. He has secured 100 in maths, 100 in science, 40 in social, 50 in Hindi and 75 in English. Individually, we can see that the student is a top scorer in maths and science. He is an average scorer in English, while he is a below average performer in Hindi and social. My priority is to find out his overall performance in academics. So, I need to find a value of X that represents the entire data. That value is found using the measures of central tendency. Suppose I have a data set with different values. To draw conclusion regarding this data, we need to find out a single value that is concentrated in the center, which represents the entire data. This central value is given by measures of central tendency. Now, let us see each measure in detail. There are totally 5 measures of central tendency: mean or arithmetic mean, median, mode, geometric mean, and harmonic mean. Before using any of these measures, we need to first know the basic and important characteristics that is required in order to form a good average. First of all, the average we consider should be of rigid nature. It should be rigidly defined. It should have a predefined framework which cannot be altered as and when required. Next, it should not be affected by the extreme values. The end values should not affect the result of the average. It should be useful and applicable for further algebraic treatment. That is, it can be generalized for more and more data that is included in the formula. Then the next one is, it should not be affected much by the sample that we are drawing out of the population. The first and most used average or measure of central tendency is mean or arithmetic mean. In the previous example that we have considered of scores of a student X, we have maths is 100, science is 100, English is 75, Hindi is 50, and social is 40. The arithmetic mean for this data can be found out by adding all these values and dividing by the number of values. That is 100 plus 100 plus 75 plus 50 plus 40 divided by 5. So 73 is the value that represents the overall performance of the student X. Now, we know that data can be divided into raw data, independent or discrete data, or continuous or grouped data that we have already seen in the previous class. We will see how the arithmetic mean can be applied to raw data, discrete data, and continuous data individually with problems as examples. We know that raw data has all the values unique and the values are represented with X. So X1 will be 5, X2 is 10, X3 is 15, X4 is 20, X5 10, X6 50, and X7 100. I have the total values as n. So my n is equal to 7. The formula to find out arithmetic mean, which is represented as x bar, is equal to sigma I runs from 1 to n xi by small n. Here xi will take x1 if I is equal to 1, that is 5, x2 if I is equal to 2, that is 10, x3 if I is equal to 3, that is 15, so on x7 when I is equal to 7. and n value here will be 7. Now, since this symbol represents the addition, we'll add all these values: 5 plus 10 plus 15 plus 20 plus 10 plus 50 plus 100 divided by n. n is equal to 7. This is equal to 210 divided by 7, that is 30. So the arithmetic mean of the given data is 30. This is for raw data. Now let us see for discrete or ungrouped data. Now let us consider the example with respect to discrete or ungrouped data. Here we have x values, their respective frequencies. To find mean for this, first we need to multiply the column frequencies with the x values to give fx. 1 into 8, 8, 2 into 10, 20, 3 into 11, 33, so on, 9 into 6, 54. Our formula to find out arithmetic mean will be x bar is equal to sigma I runs from 1 to n fi xi by capital N, where capital N is equal to sigma fi. Sigma fi, capital N is equal to sigma fi. To find fi into xi, we need to multiply all the values of f into x, and for summation, we need to add the values of all these fx. So we'll substitute here to find x bar. X bar is equal to sigma fi xi for all I runs from 1 to n, that is value 606 divided by capital N. What is capital N? Sigma fi. That is the total of all my frequencies, which is 114. Hence, the value of x bar is given by, this is my example of group data. My data is divided into totally 6 groups with class interval 8. We need to find out first x values as the midpoint of the class intervals. The x values will be, the midpoint of these two will be 4, 12, 20, 28, 36 and 44. Now we have the values of x and f. The formula to find arithmetic mean in terms of group frequency is also x bar is equal to sigma I runs from 1 to n sigma fi xi by capital N, where capital N is equal to sigma fi. Now, let us find the values f into x to find out sigma fi xi. We need to add all these values to find the value of sigma fi xi. 1956. To get the value of capital N, we need to add all the values of the frequency. So, capital N value is 77. We'll substitute in the formula. X bar is equal to 1956 divided by 77 to get the value 25.402. The value of x bar will be 25.402. Sometimes the data may not be limited. The data may be a bit larger. Then we need to use another formula to find out arithmetic mean in terms of continuous distribution. In case the data is larger, then we need to deviate the x values in order to reduce the size so that the calculation of arithmetic mean will be easier. The formula for that will be x bar is equal to capital A plus summation I runs from 1 to n fi di by capital N. By capital N. Here capital N is nothing but sigma fi and small n is the number of values that we have. Now, capital N is equal to sigma fi. Capital A is nothing but an arbitrary value that is selected among the midpoints. Okay. Now, these are the midpoints that we have taken out of the class intervals. An arbitrary value for this can be 28. Any middle value can be my arbitrary value. Now, I'll find di is equal to xi minus a. Xi is each midpoint and a is my arbitrary value. I will subtract the arbitrary value from each value. That is 4 minus 28 is minus 24, 12 minus 28 is minus 16, 20 minus 28 is minus 8, 28 minus 28, 0, 36 minus 28 is 8 and 44 minus 28 is 16. These are my di values. Now I'll find out fi di. My total value of sigma fi di will be minus 200. So, and also summation of all these f values is 77. Since we have sigma fi di and sigma fi, I'll substitute in x bar. So average is equal to x bar, arbitrary value is 28. 28 plus sigma fi di is minus 200 divided by capital N value is 77. That is 28 minus of 200 by 77. That is equal to 25.402. Previously we have seen the application of x bar is equal to sigma fi xi by sigma fi. That is that there also we got the same value 25.402. Now for consideration, if the data is large enough, I have changed the formula to this. If we apply this formula also, we should be getting the same value 25.402. For the data which is much larger, where di is equal to xi minus a, deviation does not suffice, there we will further reduce the data by dividing this xi minus a by the size of the interval, and the interval size is 8. So we'll divide xi minus a with 8 so that we get di. A value is as usual 28 and h value is 8. Now xi minus a, 4 minus 28 is minus 24 divided by h value is 8, minus 3. Similarly, next 12 minus 28 is minus 16 divided by h value is 8, minus 2. Next 20 minus 28, minus 8 by 8 is equal to minus 1. Next is 0. 36 minus 28, 8 by h value 8 is equal to 1. 44 minus 28, 16 by h value is equal to 2. These will be my di values now. Now we need to find out fi di to substitute in the formula. Fi di will be 8 into minus 3 minus 24. Next is 7 into minus 2 minus 14. 16 into minus 1 minus 16. 24 into 0 0. 15 into 1 15. 7 into 2 14. Plus 14 and minus 14 gets cancelled. We are left with minus 1 and minus 24, minus 25. As usual, our sigma fi, that is capital N value, is 77. Now, substituting the value of sigma fi di, I have minus 25, 8 is my h value, that is the width of class interval, and 77 is the value of capital N, that is sigma fi. So that will be 28 minus 200 divided by 77, which is 25.402. So let me remind you that in case of grouped data, if the data is limited, we can simply go with x bar is equal to sigma fi xi by capital N. If the data is a little bit large, then we go for deviation method, where deviation di will be xi minus a and a will be by arbitrary value. If the data is much larger, we go for step deviation method, where we consider with respect to the interval h, where di will be xi minus a by h, and the formula will be a plus h into sigma fi di by capital N. The answer will yield the same for all these three methods. Thanks for watching. In the next video, we'll see how the median is applicable to raw data, discrete data, and grouped data. Stay connected.